Hey, welcome to CPM 2. This is Module 2, Lesson 6. We're going over the rectangular coordinate system. So the first thing we're doing is defining this rectangular coordinate system and plotting ordered pairs. So the horizontal number line, which is this right here, think horizon. The horizontal number line is called the x-axis, while the vertical number line is called the y-axis. It says the point where the x-axis crosses the y-axis with the coordinate 0, 0, this is the origin, which you can see is right here. So it's right here in the very center where these two lines cross. The axis divides the plane into 4 regions. These are called quadrants. All right, so we need to graph a pair that's corresponding to your ordered pair. Your ordered pair is always in the form of x, comma, y. So x is first, then y. So first, number 1, we start at the origin. So you're always going to start right here in the middle. You are going to move x units left or right along the x-axis first, right if it's positive, left if it's negative. So you're going to start here and you're going to go this way if x is positive, or you're going to start here and go this way if x is negative, just the way these numbers are on this number line. Then from there, move up or down along the y-axis, up if y is positive, down if y is negative. So we're starting at the origin. You're going to move one way, either to the right or to the left. If you've moved to the right, let's say it's 4, then you're from this point here, which isn't really a point, from this location, then you're going to either go up if y is positive or down if it's negative, or vice versa. If x is negative, you'll go negative first, then up if y is positive, down if y is negative. We are going to remember OU. So sorry if you're a Texas fan or an OSU fan, but we're going to remember OU. And what we mean by OU is when you are plotting an ordered pair, you are going to go, let's do this. You are going to go over, that's the O part. You are going to go over left, you're going to go over side to side, before you go up or down. Okay, so that's what I mean by OU. You're going to go over side to side before you go up or down. So, in example 1, for the following, plot each ordered pair, state which quadrant, if any, the point lies on. So I guess I didn't talk about that up here. One of our definition words is that the axis divides the plane into 4 regions, which are called quadrants. These quadrants are divided up. In this first one, where you've got positive, positive, positive x, positive y, that is your quadrant 1. So from quadrant 1, go counterclockwise. So then we have quadrant 2, quadrant 3, and then lastly quadrant 4. So just remember, you start right here in quadrant 1 where it's positive, positive, and then go counterclockwise 2, 3, and then 4. So in our example 1, we're not only going to plot these, then we're also going to state which quadrant, if any, that they are in. So on A, it's kind of hard to do this since you can't see my pencil and where I'm moving, so I am going to make little lines, but you don't really want to make these lines when you plot your points. So on A, we are plotting point A, which is 5, 3. So this is your X, then your Y. So you're going to move along your x-axis first, so we're going over side to side first. So from the origin, and I'm actually going to make this bigger as well. Okay. From the origin, which is this middle one here, we want to go over positive 1, 2, 3, 4, 5. Then from this point, I need to now go up 3 since that's a positive 3. So we'll go up 1, 2, 3. That is our point right there. Okay, so let me show you again. And just so you guys know, when I start at the origin, this is not 1 right here because I have not moved. So we're not going to say 1, 2, 3. When you start at this origin, that's ground 0. So you're moving over 1, 2, oops, slipped. 1, 2, 3, 4, 5. Then from here you go up 1, 2, 3. So our point 1, 2, 3 is right here. And so after we put a dot right there for that ordered pair, we're going to label that point A. So we went to the right 5 and then up 3. Okay, our next one, now we've got -5, +4. Remembering OU. So I'm going over side to side, -5. So 1, 2, 3, 4, 5, and then up 4 on my Y. 1, 2, 3, 4. That's my point right there. Okay, so one more time. From the origin, we're going 1, 2, 3, 4, 5. We're going this way since it's negative. And then this is positive, so we're going up. So from this spot, 1, 2, 3, 4. Okay, so we'll label that B. So we went left and then up. Okay, my next point, -2, -3. So we're still using OU, so over side to side before we go up or down. So -2 means I'm going to the left 2, so 1, 2. And then -3 means I'm going down 3. 1, 2, 3. So that's my spot right there. Okay, that's C. Slide this over some. Okay, now we need to, on D, (6, -1). So +6 means I'm going to the right 6, and then -1 means I'm going down 1. So from the origin, 1, 2, 3, 4, 5, 6 to the right, and then from this spot, one more down. So this is point D. E, these ones with zeros in them get a little bit confusing. You still just got to remember your OU. We're going over side to side before we go up or down. So because this 0 is first, that means I'm going 0 left or right. Then this 2 means I'm going 2 up. So from the origin, we're not going to the left, we're not going to the right since it's 0. But from the origin, I'm going 1, 2 up. So this is my point E. And then my last point here, F, still using OU, so I'm going over side to side before I go up or down. So now, because we've got -4, that means I'm going -4 to the left, and then 0 up or down. So we're going 1, 2, 3, 4, and then 0 up nor down. So it's right here. 1, 2, 3, 4. And that is F. Okay, so now for all of these, I kind of skipped the second part of this question. After you go and plot it, we are supposed to state what quadrant we are in. So use this little chart right here to kind of help you. But A is in quadrant 1. B right here is in quadrant 2. C is in quadrant 3. D is in quadrant 4. Now, because my E is on my y-axis, it's not really in a quadrant. So you could technically leave it blank, and that's why it says if any. If it's on an axis, it's not technically in a quadrant. So you could just leave that blank, or you could say that that is on the y-axis. And then same thing with F. Because it's on this x-axis, it is not technically in a quadrant. So you could leave it blank, or you could say x-axis. All right, find the x and y coordinate to each labeled point. So A, we're using OU. So how many are we, from the origin, how many are we going over side to side? Well, from here to here, we're going not left nor right. So my x coordinate is 0. And then how many are we going up or down? From the origin, we're going up 1, 2, 3, 4. So A is at 0, 4. B, how many are we going over side to side? So from the origin, we're going over 1, 2, 3, 4, 5, 6. And then how many are we going up or down? From here, we're going not up nor down, so 0. C, from the origin, don't count down first. How many are we going over side to side? So from this origin, 1, 2, 3, 4. And then we went down, 1, 2, 3, 4. And because we went down, that's a -4. And actually, I've messed up now on twice. I originally put 4, -4. But if I'm going to the left, that means negative. So this is a -4. And same thing with my B. Because we're going from the origin to the left near all these negative numbers, that should have been a -60. So hopefully you saw that, and hopefully more importantly, I did not lose you and I did not make you more confused. Okay, D. From the origin, we are going 1, 2 over. And because we're going this way, let's make sure we get that sign right. That is -2. And then from here, we went up 1, 2, 3, 4, 5, 6. Going up is positive. E, we're from the origin. How many are we going over side to side? 1, 2, 3, 4, 5. And then from here, we're going up 1, 2. Going up is positive. And then my last one, F, from the origin. How many are we going over side to side? We're going over 1, 2. And we're going the positive direction. And then from here, we're going down 1, 2, 3, 4. So that's a -4. All right, determine whether the ordered pair is a solution. So it says right here, an ordered pair is a solution of an equation in two variables if replacing the variables by the values of the ordered pair result in a true statement. What I mean by a true statement is one side equals the other side. So for example, 17 equals 17. That's a true statement. If you get something like 14 equals 20, that is not equal, and so that would not be a solution. So these are kind of like a couple problems in one. On the first one, you got x minus 2y equals 6. So start by plugging in the first one. So we've got 6, 0. Your 6, 0 is in the ordered pair of x, y. So when we plug this in, for my x right here, I have 6. So we've got 6 minus 2 times my y is 0. So 2 times 0 minus 6. Please excuse my dog. So 2 times 0, 0 times anything is 0. That goes away. And so I'm left with 6 right here. 6 equals 6. Is this a true statement? Yes, it is. So 6, 0 is a yes. That is a solution to the ordered pair. So my next one is 3, 0. So plug in your numbers. Wilbur, stop. It's just the dryer, buddy. So your first number is your x, your second number is your y. So now you've got new numbers to plug into this same equation. So we've got x is 0. Minus 2. My y is now 3. And that's supposed to equal 6. And the question is, does it, right? So that was what we were trying to figure out on this one too. So same concept. Zeros are always nice because that 0 just goes away. But be careful with this one. When that 0 goes away, you still got a negative right here. So negative 2 times 3 is negative 6. So we got negative 6 equals 6. Well, that's not a true statement. So I'm going to put a little slash through that. That means negative 6 does not equal 6. So the answer to this one is no. This is not a solution. Okay. Okay, sorry for the long pause. I was trying to think the best way to go about this next one with the fraction, because next module is when we're going to go over all of our fraction rules. What I would say is the easiest way to do this is to change this to a decimal. That decimal is a negative 2.5. And so that's what we'll use when we plug this in. So I'm going to go ahead and change this. So we've got 1 and negative 2.5. And so plug in your information. Your x and y are these two numbers. And so plug these in. So we've got x, my x is 1. So 1 minus 2 times my y. My y is at negative 2.5. And again, does that equal 6? So order of operations does to multiply. So right here, 2 times a negative 2.5 is a positive 5. So I've got 1 plus 5. Now, if you can stop right here if you'd like to, and you can say, I know 1 plus 5, yes, equals 6. Or you can take a step further and say 1 plus 5 is 6, so now we get 6 equals 6. So I don't really care where you stop it on that one. But then this one here is a yes. Okay, let's try again, but we're going to go a little bit faster on this one. So I get 1 comma 4. So 1 is my x, 4 is my y. So plug it into our new equation. So I have 5 times 1 plus 4. And we've got to figure out, does that equal 15? So 5 times 1 is 5. So kind of the same thing as like this one here. You can stop it right there and say, I know 5 plus 4 does not equal 15. Or take it one more step and say 9 does not equal 15. But either way, this one's a no. Then we have 2, 5. So 2 is my x, 5 is my y. So we've got 5 times 2 plus 5. Does that equal 15? We get 10 plus 5 equals 15. You can stop there or say 15 equals 15. So that's a yes. And then we have 0 comma 15. So here's my x, here's my y. So we've got 5 times, let me move this down a little bit. We've got 5 times 0 plus 15. And does that equal 15? Well, same as the first couple ones that we did. 0 times anything is 0, so that just goes away. And so now I'm left with 15 equals 15. So that works. So this is a yes. Okay, we're going to take this same thing and kind of use it in a different way on this next page. Oh, I forgot I had another example of this. Darn it. Okay, let's do another one, guys. And I included this one because, again, we haven't gone over fraction rules yet. But I think your homework's going to have some fractions on it. So hopefully that's the only reason I included it. When you get this equation like this, this is the same thing as x equals 1y, or just y over 4. Okay, so I'm doing 1 times y to get y on top, and then that 4 stays on the bottom of your fraction. So now just plug these in. So in that first ordered pair, you've got 1, 4. And so that means x is 1, y is 4. So we've got 1 equals y over 4. My y is 4. So this is another one. You can stop right here, or you can say 1 equals 1. But we get a yes. My next ordered pair is 8, 2. So 8 is my x, 2 is my y. So we get x equals, which is 8 equals, and then x over 4, y over 4. And y is 2, so 2 over 4. Those are definitely not equal. That gets you 8 equals 1/2. So that one is a no. And then your last one, 0, 0. You got x equals, so that's 0 equals y over 4. My y is 0. You can stop it there. Or 0 divided by anything is 0. So we got a yes there. Okay, so when you get a problem like this right here, rearrange it so that it's a little bit easier to solve, especially since we haven't done fractions yet. Okay, so example 4 here is what I was more thinking of that we had. It says here, if one coordinate of an ordered pair is known for an equation, find the other coordinate through substitution and solving the resulting equation. So they're going to give you half of an ordered pair. Because they give you the first number here, that means they're giving you x. So they're wanting you to solve for y. You are completing this ordered pair. So this first one, we've got x is 0, so plug that in to this x here. So I have 3 times 0 plus the rest of it, 2y equals 12. So now solve this equation. So 3 times 0 goes away. So I'm left with 2y equals 12. Divide by both sides by 2. And we get y equals 6. So to finish this ordered pair, now it's 0, 6. Okay, now on this one, now I do not have x, but they give me y. So when y is 0, now plug in a 0 for this y here. So we get 3x plus 2 times 0 equals 12. Well, same thing. 0 times anything is 0, so that goes away. So I've got 3x equals 12. Divide both sides by 3. And we've got x equals 4. So to finish this ordered pair, now it's 4, 0. And then lastly on this one, now they're giving me x is 2. So plug in a 2 for your x here. So 3 times 2 plus 2y equals 12. So we've got 6 plus 2y equals 12. Solve this for y, so this one's a two-step equation now. Opposite of a positive 6 is a negative 6. So subtract that from both sides of your equal sign. These cancel. So I'm left with 2y equals 12 minus 6 is 6. Divide by 2. And you get y equals 3. Okay, let's do one more example like this one. And then we're going to kind of put it all together. So on this one, same thing as what we did on that last fraction one. When they give you this fraction, we are doing 1 times y. 1 times y is y. And it's all over 3, so that 3 stays on the bottom. So this becomes x equals y over 3. Now, because this one is negative here, you need to choose where you want your negative. We can make this a negative y over 3, but the easiest thing to do is make this a y over negative 3. So to solve this equation, we're actually going to use this one here instead of that 1/3 in front. So on this first equation, they are giving me y. So when y is 0, solve this. So I've got x equals my y, 0 over negative 3. Well, 0 divided by anything is 0, so we get x is 0. So that ordered pair is 0, 0. Okay, now on this one, now they're giving me x, we are solving for y. So if x is 4, that means I've got 4 here. 4 equals y over -3. So solve this for y. So opposite of dividing by -3 is to multiply by -3. So -3 times 4 gives me -12. -3 and 3 cancel each other out, and we're just left with y. That was kind of hard to write in, but that's a -12 there. Okay, and then last one, they're telling me y is 9. We don't have x, but we are given y. So we've got y equals 9. So plug that in here. So I've got x equals 9 divided by -3. Well, 9 divided by -3 is -3. Okay. These down here are the exact same thing as these up here. They're just giving you part of it in a different way. Now they're telling you x is -1. What is y? We saw this up here as negative, if I can make this look halfway decent, we saw this as -1 comma some space 0. That's what this right here means, but it's the exact same thing. So this first one here, when x is 1, sorry, -1, plug that in for your x here. So we got y equals 3 times -1. So that means y is -3. So we can put that here in this table. Okay, move on to part B. Now they're telling you y is 0, so solve for x. So when y is 0, we get 0 here. 0 equals 3x. Solve for x. So this is 3 times x. The opposite of that is to divide. That cancels there. 0 divided by anything is 0, so we get 0 equals x. Now do the same thing for C. Now they're telling you -9 is y. Solve for x. So y equals -9. We're going to put that -9 in place of this y. So we get -9 equals 3x. Same thing as over here. Divide by 3. 3's cancel. -9 divided by 3 is -3. So you can put -3 in here. Okay, same thing on B. If you don't like this, rewrite it the same way we wrote this. So this equation here becomes y equals 1 times x is x. It's over 2, so keep 2 on the bottom. And then -5. So on part A, they're telling you x is -2, so plug that in here. So when x is -2, we get y equals -2 divide by 2 minus 5. -2 divided by 2 is -1. And -1 minus 5 is -6. I love these 0 ones. These 0 ones make everything so easy. When they tell me x is 0, we're plugging that in for this x again. So y equals 0 divided by 2 minus 5. Same thing whenever you multiply something by 0, it's 0. Whenever you divide something by 0, it's 0 as well. So that goes away. So we get y equals, be careful that with that 5, there's a negative in front. So y equals -5. And now plug in 0 for your y. So y equals 0. Let me move this up a little bit. In place of this y, we now have 0 equals x over 2 minus 5. So solve this for x. Opposite of subtracting 5 is to add it. So 0 plus 5 is 5. We got 5 equals x over 2. This bar right here means divide. The opposite of divide is to multiply. So we'll multiply that 2 over. Those cancel. 2 times 5 is 10. So we get 10 equals x. So we can put that in there. All right, guys, you know the drill. Let me know if you have any questions. Pause this video as you need to.